All right, in this lesson, we're going to take a look at adding and subtracting radical expressions. And the idea is if you want to add and subtract radicals, they have to be the same index. So these numbers have to be the same. And then what you do is you add any number on the outside together as long as the index and the insides are the same. So if I have what I just wrote off the side here, a nth root of x plus b nth root of x, you can make this a plus b parentheses nth root of x. But notice that the nth root of x has to be the same because it's just like a variable. These things, but they'll be numbers. So for example, here, this 24 and this 54, I can't add those together unless I can simplify, which is what we have to try to do, to then subsequently add them together. So what I want to look at is the 24, and I want to notice that the 24 has a 4 inside of it, 4 times 6. And so I could rewrite this to be the square root of 4 times 6. The square root of 4 is 2, so I can make this a 2 square root of 6. Well, there's still being a 3 out in front, so it's really 3 times 2 times the square root of 6. Over here at the 54, I can do the same work, and there's a 6 inside there as well. 54 is divisible by 9, so I could rewrite this to be the square root of 9 times 6. Well, 9 has a square root of 3. So we say this is really 3 square root of 6. So notice how I'm going to add these together. Notice how they both simplified to have a square root of 6 in its most simplified form. So the 3, and over here in front, the 2 times the 3 can be added together with with both of them being the square root of 6. So this rewrites to be 3 times 2 plus 3 square root of 6. So the numbers in the front get added together. Now this 3 times 2 is really a 6 plus 3 square root of 6. So the final result for this problem is 9 square root of 6. So we take each square root, simplify, as we learned in the previous lesson, by pulling out any squares, and then we add those numbers if the leftover index is the same. In this case, index was square root of 6 in both cases. So we had 6 square roots of 6 here, so it's really a 6 square root of 6 plus a 3. Add those together and made 9 square roots of 6. So let's take a look at the next problem. Here we have 20 and 45. 20 has a 4 built in, so this is really a square root of 4 times 5x. And this is really the square root of 9 times 5x. With a minus sign in the middle and the 2 out in front. So the goal is for us to recognize the square root of 4 can pull out as a 2 square root of 5x times the 2 out in front that's still there. Minus this 9 is really a 3. The square root of 9 is 3 square root of 5x. So we square rooted the 9, got 3. And then this is really 4. So this is going to be 4 minus 3 5x's. So we bring the 4 and the 3 together, so make this 4 minus 3, and then just write square root of 5x left over. Because there's 4 of them, and you're taking away 3. The final answer is 1 square root of 5x. You don't have to write the 1, but I'll leave it there for effect. Now this last example is just one that you would call prime or something, and just leave it alone. There's no way to make the radicals the same index or values, so 2 square roots of 3 minus 4 square roots of 5, you would leave it alone. So sometimes they are prime. So continuing with cube roots now. The cube root of 16 is not an exact number. We actually are going to have a cube root left over, but there is an 8 inside of there times 2. The cube root of 8 times 2 allows you to take the cube root of the 8 and take a 2 out, and the cube root of this 2 is still going to be left. So 2 cube root of 2 with this 2 that's in front hanging out. So lots of 2's there. Apologize for all the 2's. But the 16 breaks up to be 8 times 2. Cube root of 8 is this 2 in front, and the cube root of 2 stuck. This 2 hanging out. So really this turns into 4 cube roots of 2. So when we're looking at the 54, we're trying to decide if there's a cube that goes in there. And we know 54 is divisible by 9, but 9 is a square. So we're going to do 54 divided by the next one up for 3 would be 27. And it does go in. This is 27 times 2. So the cube root of 27 times 2 allows us to make this a cube root of 27, a 3 cube root of 2. And we bring down this minus 5, so it'll be minus 5 times that. So this second cube root turns out to be a minus 15 cube root of 2. So the real problem, after all this work so far, is 4 minus 15 cube roots of 2. So we have 4 cube roots of 2, and we're taking away 15 cube roots of 2. So we do 4 minus 15 to be negative 11 cube root of 2 as our final answer for this problem. Now this last one on the screen, we have some variables in the mix. So what we want to do is, as before, I'm going to erase this a little bit just to make it stand out, is try to divide the index by any powers. Well, these ones, and this first one, is the most simplified form because 3 doesn't go into the 2, and this is a 1. So that one's done. The second radical needs to be simplified, though. Notice there is a cube root of 8, so that's going to pull a 2 out, and this is really x to the 5/3, y to the 4/3. And as I showed in previous lessons, this 5/3 and 4/3 need to be rewritten so that you see it as an x to the 1 and 2/3, and the y is a 1 and 1/3. What that allows me to do is take this 1 as a cube root that came out, but 2/3 would be left over. So this is really, I'll take the x to the 1, y to the 1, and then the leftover x to the 2/3, y to the 1/3 separately. So we can see that this part, the index for both of those is 3. So that's really a cube root of xy, where x is squared, y is to the first power, with an xy out in front. This 2 is still in front of that. So this is the simplified version of this second radical. So the real goal of the problem is for us to have rewritten that second piece and understand the problem to be, from the beginning, 2 cube roots of x squared y plus 2xy cube root of x squared y. And it really isn't that exciting because now that I got there, all I can do is just rewrite this piece plus that piece. But I can't even do anything with it because the xy is not going to allow me to add those together. So what I mean by that is, I'm going to erase this so I can just write it below, is I put these together, where this is 2 plus 2xy in parentheses, and then you have the cube root of x squared y. I can't make it a 4. I can't put these 2's together because this 2 has an xy attached to it. So they're not like terms. So this, like I said, that problem wasn't very exciting except for figuring out how to simplify this second radical down to this. And then we do another one. This one has a cube root, and this one does not. So that's a problem. But first thing we want to do is simplify, if we can, the 64. The cube root of 64, we have inside the 64 a 16 or just a 4. So this is a 4, and then we have a, so the cube root of 64 is 4, and then we have x to the 4th. We rewrite that to be x to the 4/3, and think it through as the previous problem, where we're going to have x to the 1 and 1/3. So 1's going to come out, 1x, and then a cube root of x to the first will be left. That's what this 1/3 does. So it's both of them as a product. So this second radical rewrites to be 12. So 3 times the 4 make the 12. And then bring this over, x cube root of x. Bringing the first one down, we can do the square root of the 4, which is 2. Bring down the 5. It's going to eventually make 10. But then here we've got x to the third, so we want to see that as x to the 3 halves. So there's a 2 right there. So there will be one radical, one x that comes out. So we have x to the 1 and a half. That's what 3 halves is. And so this is 10, and then this x to the 1 stays out, but then this x to the 1 half makes a square root of x to the 1. All that to get to here, where you're pretty well stuck because we don't have common indexes. Now we have radicals that look ugly. The idea is I'm supposed to add them together or subtract them. The key here is that I have to have common denominators, essentially. And so what you want to work with is this square root to see this is really 2. The 2 can be, it's really over a 1. So it's really 2 square root of 75 over the square root of 16. Plus, I'm going to put the 4 up top, 4 square root of 8 over the square root of 32. Now, actually backing that up a little bit, the 8 over the 32, you could rewrite just that part as one square root. See how I put the square root and separated that to be two quotients, the square root of top and bottom, I meant to say. And then over here, I can make that the other way. I make it 8 over 32, which allows me to reduce vertically before I square root. And 8 goes into 32 4 times. So this is really 4 times the square root of 1/4. So this left fraction, continuing, is 2 square root of 75. Square root of 16 is 4. Plus 4 times the square root of 1/4 is really just 4 times 1/2. And then you continue to just simplify. Half of 4 is 2. So this is really 2 square root of 75 over 4 plus 2. And then if you have to combine it together, we're just going to put this 2 over a 1, make common denominators, make this times top and bottom by 2, so that I can make this a 2 square root of 75 over 4 to 7, plus 4 over, I meant to say times top and bottom by 4, and then I get an 8 over 4. So final answer, 2 square root of 75 over 4 plus 8. Now that plus 8 is not underneath the square root, it's just sitting there. But that's combining, simplifying, it's modifying the problem. There's a little bit uglier one with a cube root. And so what we want to do here is just rewrite this cube root part to go up to the top and the bottom separately and try to simplify as much as possible. So I have 10 cube root of 5 over the cube root of x to the 6th. The whole game here is just knowing that you can split it up. So then it's minus 3 cube root of 4 over the cube root of x to the 9. And then I want common denominators so I can add the tops. The cube root of x to the 6th is going to be x squared because I just divide the powers. It's just going to be x to the 6 over 3, and the 6 over 3 divides out to be 2. And then the same thing here, this is really just x to the 9/3, so this denominator is x to the 3rd. So if I rewrite it, I have 10 cube root of 5 over x squared minus 3 cube root of 4 over x to the 3rd. To make common denominators, I would just multiply top and bottom of this first one by 1x, and then I'd have x to the 3rd on the bottom. So I can make this 10x cube root of 5 minus 3 cube root of 4 all over x to the third. And again, it's just a matter of simplifying the radicals, not having an irrational denominator. It all works out here when you simplify.